To perform transfer learning, you need 4 things. First, you need data to train with. This means you need example images for which you already have the correct label. In machine learning terminology, this is known as supervised learning. The network will learn from examples with a known correct answer. Second, you'll need a network to train. The point of transfer learning is that you'll get that network by starting with a pre-trained network and then modifying it. Third, you need to specify a loss function. Training involves applying an algorithm that iteratively improves the network's ability to correctly identify the training images. The loss function evaluates the network by measuring the error between the correct label from your training data and the predicted value from the network. For standard tasks, you can select from built-in loss functions, like cross-entropy loss for classification. Last, you'll need to specify a set of training options. The training algorithm can be fine-tuned with many parameters, such as how many training images to use at each step, the maximum number of iterations to take, the learning rate, how aggressively new iterations should change the network parameters, and so on. So, MATLAB needs you to specify a set of these training options when you train a network. But don't worry, you can often just use the default values for most parameters. Once you have these 4 components, the training data, the network, the loss function, and the options for the training algorithm, well, training is pretty easy. Pass the 4 pieces to the trainNet function and wait for the trained network to be returned as an output. In the next activities, you'll create the components needed to perform transfer learning for the flower images.